Hello, everyone. Good morning, good afternoon, and good evening, wherever you are. Myself, Harsh Soni, and I would be moderating this session. So, dear authors and invited guests, welcome to Technical Session 9A. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the third international conference, third World Conference on Information System for Business Management. The third edition of the conference is being organized in a hybrid mode. The physical event is organized today in Bangkok, Thailand, and the physical event is organized yesterday in Bangkok, Thailand. My apologies. And the virtual event is being held today and yesterday through Zoom. Through Zoom, 12th and 13th of September, 2024. I hope you will enjoy the knowledgeable and interactive sessions through the day. So in this session, we have 6 presentations, and each presenter will be given 12 minutes for the presentation and 3 minutes for the question and answers. So on 10 minutes, I will raise a gentle reminder so that you can conclude your presentation on time. There is another request for all the presenters that you may all please stay connected with us till the closing remarks so we can capture the good memories of this virtual conference. Further, if you have any query or any update, you can directly write it to me in the chat box. So just before we start the session, I would like to introduce you all to the chair for the session, Dr. Astha Parikh. Yes. Dr. Astha is assistant professor and selection grade CS and IT at ISBM University, Jaipur, India. And she is since March 2010. Her research interests lie in the area of programming, languages, data mining, cloud computing, and sentiment analysis. Welcome you, ma'am.
Thank you.
Okay. So starting with the papers, first we have Atharva Kale. And Atharva is going to presenting on compresso and efficient cloud storage. Dear presenter, you may please proceed with the presentation. So Atharva is not here. So moving forward for the next presentation. Next, we have machine learning based trust management model for fog to fog network. And it's going to be presenting by Shino Singh. Dear presenter, are you there? Okay. She's not also here. Moving forward for next. Next, we have Tapan Sharakat, and he's going to presenting on mobile application for tracking and assisting the visually impaired students, University of Fayao.
Okay, good morning. Is Thapanapong Sararat. I'm representing from Uda team. Today, I'm pleased to present our research on a mobile application for the tracking as and assistant visually impaired student at the University of Payao. This project aims to leverage technology to improve the quality of life and enhance the independence of visually impaired students on our campus located at the University of Payao in Thailand. To understand the context of our research, let's first take a look at the border situation of people with this disability in Thailand. As of 2023, the country has approximately 2.18 million disabled individuals, of which 184,006 22 or 8.47% are visually impaired. A significant portion, around 55.3%, are over the age of 60. while the 39.31% are of working age. Now, let's consider the key challenge faced by visually impaired individuals in Thailand. One of the primary challenges is the difficult in performing daily tasks and securing employment, which significant impact their ability to live independently and maintain financial stability. Additionally, the digital device, the lack of access to information technology further exacerbate ex- exacerbate this technology gap limits opportunity to learn communication and employment, particularly in the rapidly digitalized world. Our research focused on objective. Give this challenge, we saw the need of a technology solution that could support visually impaired individuals, particularly in the context of education. At the University of the Paya, we developed an AI-powered mobile application designed to track and assist visual impaired students. The app provides real-time location update and facilitates communication with the caregiver, offering essential support to help students navigate their surrounding and enhance their independence. Our research focused on three key objects to study AI technology applicable to this context, developing the model application and evaluating users' satisfaction with the application. For material and method, our research target two main user group, the caregiver and visual impaired student. The application we developed consists of 11 key modules, including registration, login, emergency call, and monitoring functions. This comprehensive design ensures that both visually impaired students and their caregiver can easier navigate and use the application for assistance and tracking. Here, you can see the user can diagram outlining how user interact with the system. This instructed approach allowed us to build a robust system that meet the need of our target user. This is the interface of application. To evaluate the application, we use the black box testing technique on a sample group of 30 computer science students. We assessed 5 key areas. First, user need. Second, system operation. Third, usability. Fourth, processing. Fifth, reliability and security. The result of the satisfaction survey we overwhelmingly positive. We achieved an overall satisfaction score of 4.21 out of 5, with the highest ranks areas being system usability score 4.49. The system processing dimension received the lowest score of 3.75, but it still fell within the very satisfied range. Our research successfully met all these objectives, all three objectives. The highest level of user satisfaction reflect the app effectiveness in meeting the needs of both visually impaired students and their caregiver. The integration of AI technology or for location tracking greatly enhance the functionality of the application. Some critical findings include the importance of the user-friendly interface, particularly of visually impaired user, the potential of expand AI capabilities beyond just image processing and location analysis, such as implementing real-time object recognition and advanced navigation assistant. We also we also know the need for improved image to text conversion in the Thai language to better serve local user. Additionally, the emergency notification and GPS tracking feature were highly appreciated by user, highlighting their importance in ensuring safety for visual impaired students. While we successful achieving our research objective, we acknowledge certain limitation as an undergraduate project. Some areas like data collection may have certain accuracy limitation. However, we remain committed to further improving and refining the application in future iteration. In conclusion, our research has a successfully development of mobile application that show great potential for particle application in assistive visually impaired student. We met all the research objective, including study AI. Sorry about that. Developing the app and achieved a high user satisfaction score of 4.21. This work hold great promise for broader implement and further development of better support visually impaired student in the future. Thank you. You may ask me any questions.
Thank you, sir. I request session chair, ma'am, do you have any questions?
Yes. So can this app be customized based on the individual preference and needs to the user?
Sorry, I can't hear it clear.
Hello. Yeah.
Yes.
So, what challenges did you face while developing this application, particularly in ensuring real-time accuracy?
Our challenge is how to collect the the group for test our application, because we have to 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 choose some group that have a potential to test it, to have a real data, I think. So in the future research, we should make a better how to collect the data.
Okay. Thank you.
Thank you.
Thank you, ma'am. Thank you, sir. Now we are moving towards the next presentation of the day. For the next presentation, we are like to call Swasti Rai for paper title Securing Smart Irrigation System with Rust and Beam. I request the presenter to kindly proceed with their presentation.
Hello, Karthik. Am I audible?
Yes, sir, you're audible to us.
Okay, so I'll start. I'll share my screen.
Yes, sir, you can share your screen now.
Okay. So good morning, everyone. Myself Swasti Rai. I'm currently resident of India. So our paper would be. So I will present in the part from alongside our group. I'll be the face of the presentation. So Our present mainly, this is a paper presentation. So our team is group ID 48. My team includes Swanand, Lokik, Nishant, and under guidance of our professor Avinash Golande sir. So the introduction is in India, 70% of the people or the workforce work directly or indirectly under agriculture. As India is also a developing economy, we should focus on things that would harness this power and to level up the skills that farmers use in agriculture. So along with the numerous parts of farming, the along being the 70% being the powerhouse of 70% workforce of India, farmers and the farming only contribute to 30% of the Indian GDP, which is a significant less portion considered the amount of manforce present in it. So when we were researching for how to address this particular issue, we found out that to address this particular issue, we need to have a IoT based system and to automate the farming equipments like it is in developed countries like USA and Europe. All right, so it can benefit society in a particular way, and we can and then in the future we can have farmers who earn more, who can benefit for the country more, and then we can increase our exports, and that will increase our GDP in a particular country. So when we were going through various surveys, like we read a bunch of papers, all and based on IoT, most of them were focusing on which sensors and which equipment to be used in a particular way to, let's say, take data of pH of the soil, or to get data of what how the soil is and the moisture of the soil, and when to irrigate the plants in a particular way, let's say drip irrigation or any other irrigation whatsoever. So but no one no none of the paper and the future scope of the paper was the security. So no other paper were providing the security of the data transmission and how the sensors communicate with each other. If, let's say, a third person or the man in the middle attacks can be done, he can alter the data in the particular system, which can lead to a farmer choosing a different fertilizer, choosing a different amount of water quantity, and that can cause the crop to be harmed, and that can lead to a bad irrigation and a bad crop production. So these are the bunch of papers that we studied as a team, and we got to know that we need to have a secure, we need to provide the security on IoT based communication. See, that this is the observation we use. We observed the lack of security. They were hard to use as the farmers are not, assuming the farmers are not that prone to the technology, they won't be understanding how the systems are working and how the sensors are showing the data in a particular way. So we needed security. We needed to have a good UI UX design so the farmers can understand easily. And the most of the system were expensive. Like to host the system on a web and do all the certain kind of stuff, it was expensive for a farmer, considering how they have a tight budgets. So the problem statement was to make a user-friendly smart irrigation systems which are cost efficient using IoT, which will be cost efficient to the farmer, and it can help him to raise a better crop production. So these are the basic objectives that we needed to solve. So the basic requirements were a hardware. So we take hardware as a microcontroller, sensors as per need, like electrical and other departments have various list of sensors and various research papers other farmers can read into to have which particular sensor they should use for which particular soil and which particular crop. And the requirements is basic in software requirements are basically Rust embedded coding, front end framework, simulator, and development tools. Okay, so this is the basic system architecture. The farmers gets into a web platform. Comes to authorization using MQTT protocol. Then they're using web API. We transfer the data to the web host using ByteBeam, and in ByteBeam we basically host all the data and host all the graphs that can be easily studied by the farmer. And then using microcontroller MCU unit, we can easily start the motor, or we can set time to when the motor should start if the pH or if the humidity of a particular soil or water content of a particular soil goes below a certain level. So there can be just a motor is just an example. We can add on various sensors as well, so have a better understanding of the crop and the data. So this is the basic implementation that we did with the homegrown plants to understand what is the soil content, so we can easily figure out that which plants are watered, which plants will need more water, And as we all know, like show plants need more water compared to the regular plants. So we found out that this is the case for this, and the implementation was quite successful in a small scale. The protocols and algorithms that we're using is basically MQTT. MQTT just prevents any man in the middle and the man in the middle attacks, and provide and prevents data leaks as well. Encryption algorithms can use many the mostly protocols in the system are the Xcipher and the rest of it. So we can use them to have a secure encryption, and no one else can see the data provided by but the farmer itself. So the conclusion is, when we solve the needs of the farmer with the new technology and the insights of previous systems, we can help them to grow and adapt to technology in an efficient way. And this is how the farmers will have a better contribution to the Indian GDP, and then we'll scale our economy in a faster way, because sustainability is the main issue. Sustainability is the main issue in the future. So these are the references that we did when we were researching any for our papers. So thank you. I would like to take any questions if there are.
Thank you, sir.
What improvements or new security features do you plan to add in the system in
Uh,
future iterations?
Okay, so ma'am, basically, when the previous system that we looked into, which were designed by electrical students or civil engineering students, what they did was they basically relayed the sensor all over the farm, and they were just directly sending the data to the user directly. Like, and if you can catch on to the frequency of the MCU, if you can catch on to that particular frequency of the microcontroller, you can connect in the local network, you can directly see all the data which is taken from the farm. And let's say if you're having a if the crop is very perishable, let's say grape of a farm or a strawberry farm, which are very perishable and very sensitive, if the third person can trigger change the data or alter the data, then you might choose a different fertilizer, you might choose a different layout of the particular farm, and that can lead to bad crops and then bad profits whatsoever. So what we figure out, there is no amount of security in any given system. Like, anyone can attack it, anyone can change the data. So what we did, and the UI UX was very poor. So what we did was we took the data from the particular sensors. We provided MQTT and Cipher protocol, and then we hosted that particular data on a Bytebeam, which is very visually friendly tool, and you can see the graph very easily, and farmers can understand it in the layman terms.
Okay. Is the project open source? But how do you see the open source community contributing to improving the security and functionality of the system?
We have hosted a code on GitHub, but I don't have that right now because this is my work laptop, so I didn't get it. So, but we have it on a GitHub, so anyone can take the algorithm and how it works and contribute it further.
Okay. Thank you.
Thank you, sir. Thank you, ma'am.
Is that it, Karthik? Should I stop?
Yes, sir.
Okay, thank you.
Thank you. Now we are moving towards the next presentation. For the next presentation, I would like to call Tapananga Phone for the paper title Sign Language Detection Mobile Application for Thai Patents Using Medical Image Processing to Support Medical Consultations. I request the presenter to kindly proceed with their presentation.
This presentation is about sign language detection mobile application for Thai patient using medical image processing to support medical consultation. Active communication is critical in healthcare setting to ensure accurate diagnosis and treatment. However, deaf and hard of hearing patients face significant barriers in accessing medical service. To address this issue, we developed a mobile application that detects and interpret the Thai sign language, specifically designed to support medical consultation. In Thailand, over 400,000 individuals have a hearing disability. Existing communication methods such as writing notes and lip reading are often inadequate for clear communication in medical environment. This gap underscore the urgent needs for innovation technology-driven solution. The objective of our research are to develop a mobile application that detect and interpret Thai sign language to assist in medical consultation. Uh, Second, to create a consultation chatbot or for Thai patient to inquire about basic medical treatment information. The last to assess user satisfaction with the mobile application. For methodology, we follow the research and development process and apply the software developed life cycle. Our study focus on two target groups, 30 patients, including people who deaf or hard of hearing, and 3 medical personnel with at least 5 years of experience. The research instruments were to sign language detect mobile application and a questionnaire as to assess user satisfaction. We collect 60 healthcare related sign language vocabulary and pairs stored in MP4 video format and JPG image with a resolution 512 multiple 512 pixel. The site language gadget were sourced from the Thai Telecommunicate Relay Service and the Sukhothai Thammathirat Open University website. This dataset ensure comprehensive coverage of common medical terms. The two users developed the application were Flutter Dart and TensorFlow Lite and Testable Machine. Our system consists of two main components, converting sight language gestures into text, enabling communication via healthcare providers, facilitating interaction through a chatbot or direct communication with medical personnel. This system aims to streamline communication between deaf or hard of hearing patient and healthcare provider, ensuring clarity and accuracy in medical consultation. This figure illustrated the communication system. First is sign language input. Patient use a sign language to communication. Second, digital camera capture. A smartphone camera capture the gestures. Third, medical image processing. The image are processed to recognize the sign language. Fourth, the text display. The recognized sites are converted to in-text. Fifth, chatbot interaction. The text processing by the chatbot system. Fourth, medical personal interaction. Healthcare provider receive the information that respond accordingly. This system ensure that messages are accurately converted from patient to medical personnel. The application offer a user-friendly interface with features such as login, registration, site language, vocabulary search, and symptom categorization. User can interact with our chatbot for basic medical queries and use their mobile camera for real-time sign language detection. Okay, this research tests the application with 30 patients, include patient in the medical staff. The result indicates high acceptance and satisfaction level with the site recognition accuracy of 69.61%. This demonstrates the application potential to effectively support healthcare communication. Our finding revealed that the application significant improves in communication for deaf and hard of hearing patients. The user feedback was overwhelmingly positive. However, we did face challenge with the lower recognition accuracy for certain sites. mainly due to image quality. Effective communication is vital in healthcare, and our application addresses these critical needs. We see opportunity to future enhancement in model accuracy and broader applications such as general sign language education and addition medical consultation. While this project focus on city health related side gesture feature research, should expand this range, improving data quality and mobile accuracy the while accuracy will be the key to make the application for reliable and effective. In conclusion, our sign language detection mobile application represent a significant step toward inclusive healthcare communication. The prototype show promising result, but continue improvement to collaboration with healthcare provide are necessary to fully realize its potential. In future work, we're moving forward. We plan to use higher quality data set, explore advanced deep learning technique, expand vocabulary set, and collaborate with the healthcare organization to enhance the application utilities and real world applicability. You may ask me a questions. Thank you.
Thank you, sir.
Thank you.
I request our respective session chair, ma'am.
Yes. So, what measures are in place to protect the sign language data and medical images from unauthorized access or breaches? Can you hear me?
Sorry. Yeah, I can hear you,
My
but
question is, what measures are in place protect the sign languages data and medical images from unauthorized access,
you mean another disability?
data privacy and security?
Oh yeah. We not research for security yet in this time.
Okay. And does
We
the app provide real-time translation of sign language during medical consultation? So, if so, and how does it ensures the accuracy and speed of translation?
excuse me.
It is I'm asking, how does the app provide real-time translation of a sign language during medical consultation?
You mean how to use or something,
Yeah,
right?
yeah.
Oh, you just there's a you just make a sign language as a camera mobile phone and they transfer to text. Yes.
Hello.
Yes.
Yeah.
Hi.
Okay, okay, got it.
Yeah, thank you.
Thank you, sir. Thank you, ma'am. Now we are moving towards the next presentation. For the next presentation, I would like to call Tapana Pong for the paper title, The Potential Development of Tourism Service and the Tourism Communication Model in a Northern National Park.
Yeah. Okay, let me share my presentation first. Okay. Can you see my presentation? Can you
Yes,
hear
yes.
me?
It's pretty
Yes.
visible to us.
Thank you. This research is about the potential tourism communication model in Northern National Park for the carbon neutral tourism support using data mining analytics. This work was conducted across Chiang Mai, Lampang, and Phayao province in Thailand. from the north of Thailand, northern north. Tourism is a crucial part of Thailand economic, but it poses significant challenges, particularly in terms of carbon emission throughout the tourism value chain. These emissions contribute to climate change, which threaten the sustainability of Thailand natural resources. According to the World Economic Forum's 2021 Travel and Tourist Development Index, Thai ranked 36 globally in tourism competitiveness, but fell to 130 in terms of environmental sustainability. The tourism industry generates carbon dioxide emission, which directly contribution to climate vulnerability, impacting the sustainability tourism resources in the country. This research aims to address these challenges by promoting sustainable tourism practice with national park in northern Thailand, namely Doi Inthanon National Park, Jaesaw National Park, and Pusang National Park. The objective of the study are the threefold. First, to analyze tourism behavior and the service potential of net zero carbon tourism. Second, to develop mechanism and communication format that support carbon natural tourism. Third, to create a tourism behavior analysis model that can aid in the development of net zero carbon tourism. Our methodology involved collecting data from 3 national parks, Doi Inthanon, Jaesaw, and Pusang. Between 2022 and 2023, we granted 1,200 samples focused on the tourist background, travel style, and travel characteristics. Here is a summary of tourist information collected from this park. This table display the energy consumption pattern and potential carbon emission from various vehicles Thai using by tourists. Were implemented in 2 pairs. The first pair involved the data collection through questionnaire and subsequent analysis. The second pair used machine learning and data mining technique to develop a tourist behavior analysis model aimed at further net zero carbon tourism. For data analysis, we employed unsupervised machine learning specifically the K-mean cluster technique and utilize the L-bar method and determine the optimal number of clusters for each park. Our result reflect a fairly balanced gender distribution among tourists. Most visitors were from the north regions of Thailand with Generation Y being the largest demographic. Sedans were most commonly used vehicles, which contribute to carbon emission. Then the energy consumption and carbon emission for tourism visiting Doi Inthanon National Park show demonstrate carbon footprint with a mean of 191.28 units. Table 3 display data for Jaesaw National Park, where tourists exhibit a low carbon footprint with a mean of 129.64 units. Table 4 shows the Pusang National Park, where the majority of tourism also had a low carbon footprint with a mean of 101.49 units. The main source of carbon emission came from traveling outside the national park, while consumption within a park contribution the least. In Table 5, show tourism cluster generates using the data mining technique to group tourists with shared characteristic. The above technique was used to determine the efficiently of clustering tourists into 5 clusters. For each national park, cluster analysis revealed that 5 clusters were optimal for all 3 parks with distinct characteristic and a unique distribution of the tourists in each cluster. We analysis show that while overall tourism behavior patterns were similar, each national park attracted a unique subset of visitors. Show the number of tourism per park. Group 2 came in cluster into the 5th cluster. The analysis uncovered different in tourist behavior and travel preference which were specific to each park. In the discussion of finding, we noticed significant difference in tourist demographic across the park. For example, Doi Intanon and Pusang attracted to generation-wide tourism, whereas Jason saw an influx on Generation C visitors. This difference had a notable impact on each park carbon footprint. The tourist cluster we identify show unique characteristics for example, cluster 1 was primary composed of tourists from central Thailand, while cluster 3 in Jason National Park consisted main of a motorcycle user. This insight can help us develop the park specific strategy for promoting sustainable tourism. A brief of the research objective and achievement related to sustainable tourism practice in Northern Thailand National Park is tourism behavior and carbon footprint analysis. Our research provides a key insight into tourist behavior and environment impact, particularly to the carbon footprint of the tourism across 3 major parks, Doi Intanon, Jason, and Busan. We conducted a comparative analysis, which revealed this distinct difference in the type of visitor to each park. For example, the internal primarily attracted family-oriented tourists, whereas Jason drew adventure-seeking visitors. This information is critical for tailoring sustainability effort specific to each park visitor base. Communication and innovation for sustainable tourism. Our study also focused on developing tailored communication strategy based on the unique visitor profile of each park. For the instance, we recommend family oriented messaging to engage visitors at the Intanon, while eco-adventure theme may be more appreciated for Jason. These customized approaches can help foster environmentally conscious behavior among tourism, further supporting sustainable tourism. To be better understand tourism pattern, we employed K-mean cluster to identify distinct group of tourists across the 3 park. This model proof effective in helping use create target and management strategy at the cater to the specific need and behavior of the different tourist group while also minimizing environment impact. Future implication and recommendation. Looking ahead, our research demonstrate the potential for sustainable tourism development through data diving decision making and the use of machine learning technique. It is crucial to strike a balance between promoting tourism growth and ensuring environment conservation. The insight gained from this study lay a strong foundation for the future research and policy effort to achieve carbon neutral tourism in Thailand National Park. Thank you.
Thank you, sir. I request our session chair, ma'am. Do you have any questions, ma'am?
No. Thank you.
Okay, ma'am. Now we are moving towards the next presentation. This is the final call for the authors, Mr. Athar Kale, for the paper title Compresso and Efficient Cloud Storage. I request the presenter to kindly proceed with their presentation. Let's move towards the next call. I would like to call Shinu Singh for the paper title Machine Learning Based Trust Management Model for Fog to Fog Network. I request the presenter to kindly proceed with their presentation.
Hello,
Hello, ma'am.
this is Shiru Singh. Can I present my paper?
Yes, ma'am. You can proceed with the presentation.
Okay, thank you so much. Okay, I'm going to give a presentation on that is machine learning based trust management model for fog to fog network. Now for that outline is first we will discuss that what is the motivation behind this writing this paper, and what is the role of machine learning to create a trusted fog network. Various studies that has been carried out, the proposed model that I have done here, the conclusion and what are the future scope for that. So first is in motivation. So as we have moved from human to human communication to we use with the IoT devices. So there is a huge revolution of smart vehicles, meters and devices that has already increased the requirement of the IoT devices in the market. Now these devices will generate the massive amount of data. So to handle this massive amount of data, we require some mechanism to store that data, to process that data. So for that, cloud computing can be used. But it struggles from the limitation of it has a latency issue, and also it has less compatible for less it may not be the better solution for the time sensitive task. So that for that fog computing can address this problem state we can say that problem the fog computing can handle that they can manage they can reduce the latency. But the problem is in case of fog computing, it is the resources are limited, it is distributed, decentralized. So there also the fog nodes are having some limitations. But because of that, they need to collaborate mutually in the network for communications. So for that, how we can establish the trusted fog node in the network? That is the main motivation for this paper. Now to create the trusted fog network here. So trust evaluation means how to establish, how to evaluate or assess the trust of the fog node in the network. Why it is important? Because to identify the malicious node is very crucial here. If one node is malicious, that may make the whole network as a malicious. It is quite crucial to identify these malicious node in the network. The main challenge is that the network is dynamic. At every timestamp, the network is dynamic and is decentralized and distributed. So for that, we require a dynamic trust management system. The trust management system must be dynamic and must be distributed also. So ML we can, by using ML, we can automate the trust management process in the network. We can identify various data patterns for the reliable fog node that help us to detect the malicious node. We can assign more accurate trust score by using machine learning. Now, machine learning, in that we can use regression technique to calculate the various weights for the trust factors then we can use various classification models, SVM, that many of them are used also. That is decision tree, SVM, neural network to classify. Clustering algorithm can be used on the basis of pattern. We can create the clusters of the fog node in the network based on their behavior. Then similarly, we can use association rule mining, dimension reduction, that can enhance to identify the correlations between the various parameters for the parameters of the fog node in the network. Now this RL, so as the network is dynamic, and RL can also handle the requirement of zero knowledge. So we can use it is a quite better solution we can use for creating the generalized security mechanism for the fog network that we can handle. So some papers are already been implemented in VANET, MANET. They have used RL to make the network secure. So various studies has been carried out. So in machine learning, supervised, unsupervised, various algorithms are used, has been already used to for the network, like SVM is used for the derivation of the trust value in the for the each node in the network. Then KNN used to detect lameness detection in the dairy cattle. Then next further, a trust that is RL is used for VANET, for trust model based in the that is to create in vehicle network. Then ANN algorithm is used. Then after that, RL and KNN is also, but majority of the majority of the algorithm that are used is supervised and unsupervised. And RL is used, but they have for the some like VANET or MANET specific area or health sector specific that has been used in proposed model. So in our this proposed model, I have used reinforcement learning. And by using reinforcement learning, we can train the each fog node in the network. They themselves can detect other nodes whether it is malicious or not. We can classify the neighbors, all the neighbors in the fog network in trusted or untrusted nodes. So instead of having a centralized identity or centralized node or a few nodes as an agent to identify the malicious node in the network, we can train each node that can identify the other node based on some parameters. So in traditional trust management, we need to assign some fixed weights, initial trust code, threshold value. So these values are fixed, 0.5, fixed weight are assigned to the parameters. So by using RL, we can make these threshold value, initial values as dynamic. So as the network changes, based on the network condition, we can decide these values, and that help us to make it more secure, make it more dynamic. So the working of RL is here network is our environment. So agents are the network, fog nodes are the agents. Then the state, on the basis of state, it will take the action. The state means here is that is the trust value score. The trust value score is composed of two things like direct trust value and indirect trust value. So direct trust value means if the node is having a previous interaction with that node, so it can calculate directly. But in case of indirect, if the that is node is new to the that node is new to the other node, in that case, it will ask its neighbors about its feedback. Accordingly, it can decide that is the whether that the working of the node, that is whether that is malicious or not malicious. So accordingly, that action can be taken. So if the action is right, that node can be rewarded here. Now in proposed model, instead of having a static, we are creating the dynamic trust management. So that is adaptive trust policy, based on the network conditions, based on the fog nodes conditions. We can design the rules in that, rule policies in that. Threshold values, the whole network will decide. It is not for the specific or that is fixed or for the one node. It is depend on the network condition. So in that, in a fog node, we are having node A, B, C, D are the fog nodes. ML algorithm, I have used RL. So that algorithm is implemented all the nodes. So these nodes, they will
And you are not audible.
Ma'am, you're not audible to us.
Now, in a conclusion case, we can say we can use ML for prediction, clustering, classification, and
Ma'am, your
recommendation.
screen has not been shared.
Screen sharing.
No problem, ma'am. Can I ask you?
Yes, ma'am.
So, how frequently does the model need to be retained, and what are the computational requirements for the process?
Ma'am, can you repeat the question?
How frequently does the model need to be retained, and what are the computational requirements for this process?
So, ma'am, in case for computational requirement, currently I'm implementing this one with 20 fog nodes in the network. We have created the network for 20 fog nodes.
And what specific security threats does your model address in fog network? And how can we compare with traditional trust management solutions?
Ma'am, in this case, actually, the existing the models, they are maximum of them have that is these threshold values are maximum they have taken static, and all the models are specific for one, like only for VANET or only for MANET, because it is these are quite dynamic. So network is dynamic. There is no generalized model. So here I want to create a model. That we want to implement a model that is generalized. So on the basis of the parameters, so the network condition that should be dynamic. So these values should not be fixed. So that help us to prevent the that is network from some of the attacks. If these values are not fixed, so we can prevent them from the attacks. So if we do it, take it, we keep it as for dynamic.
Okay, thank you from my
Thank
side.
you so much. Thank you so much for your support. Thank you so much.
Thank you, ma'am.
Yeah, thank you so much, sir.
Hello, Karthik. Actually,
Yes,
I
sir.
have one message for Thapanpong Sararat.
Yes, sir.
Thapanpong, actually, we have a final submission you have submitted, but your name is not in the all author name. For a paper title, The Potential Development of Tourism Services and Tourism Communication Models in a Northern National Park for Carbon Natural Tourism Support Using Data Mining Analytics. This is the paper title that you have to check. Representative, am I audible?
I already have
Yes.
presented.
Okay, you have shared the email.
No, I mean I already presented.
No, what I'm telling you is the paper you have submitted, in that paper, your name is not there.
Yes, it's already done because the last presenter is.
No, we have your final submission. The last you have
You mean the
submitted.
potential development of tourism service, right?
Yes, correct.
Yes, I already presented.
No, what I'm telling you yet, you have to submit your final submission to the conference support ID for the same.
It is a question.
Yes, you have to submit your final submission to the support ID that your paper has not your name in that.
Yeah, yes, not that doesn't have my name in that. Yes.
You have to add your name in that paper and you have to send us back.
No, I've just presented for them.
Yes,
For
please.
Uther. Yes.
Okay, yeah, thank you.
Yes. Thank you.
Karthik, you may go ahead for the closing, please.
Thank you, sir. Thank you, sir. Now we are moving towards the closing remark of the session. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during the third version and all the previous two versions of the conference. We will be happy to have you in the fourth version in 2025. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to Springer. The publication will be live within 6 months. Kindly cooperate with the team of ISBM 2024. I also thank our session chair, Dr. Asta Parekh, for chairing the session. Ma'am, this is a token of appreciation on behalf of team ISBM 2024 and Global Knowledge Research Foundation and partners. Ma'am, I request you to kindly
Thank you.
address our participants.
Thank you so much. Thank you for inviting for this conference. I'm not able to speak. I'm bad with my throat.
Thank you, ma'am. Thanks so much for your valuable presentation. Now I request everyone to kindly turn on their cameras for a quick virtual snapshot of the conference. I request everyone to kindly turn on their cameras. Quick virtual snapshot of the conference. Thank you, everyone. Thank you, one. Stay safe, stay connected.